Dear viewers, in this video we will be exploring how to evaluate hardware elements. When developing hardware according to ISO 26262, we may come across components that are used for safety functions or monitoring, but were not originally developed to meet ISO 26262 requirements. In such scenarios, we need to assess and qualify these hardware elements to ensure they are suitable for functional safety applications. Let's get started. In this slide, we will understand where hardware element evaluation starts. First, we need a way to check whether a hardware component is safe enough to be used in future development. This process helps us to make sure that the risk of violating a safety goal or a safety requirement is low. This is done by qualifying the hardware component. You can find more details about this topic in ISO 26262 Part 5, Clause 6.4.4 and ISO 26262 Part 8, Clause 13. Hardware element qualification is needed when the failure of a hardware component can cause a hazard and the component was not developed according to ISO 26262. Such a component must be checked carefully before being used in a safety-related system. The qualification can be performed by the organization responsible for the hardware development, such as Tier 1 or Tier 2 supplier. Support from the component manufacturer is also needed, including test results and technical information about the component. The process starts by creating a hardware component list, also called as hardware bill of materials. This list includes all hardware components and their SL levels. Based on this information, the components are grouped into Class 1, Class 2, or Class 3. Each class has different qualification requirements defined in ISO 26262. Classification of hardware elements. ISO 26262 groups all hardware components into three classes: Class 1, Class 2, Class 3. In general, identifying Class 1 and Class 3 components is easier than identifying Class 2 components. Class 1 components are simple hardware components. Their output depends directly on the input. They either have no internal states or very few internal states, and we do not need to understand their internal design in detail. These components also do not have any internal safety mechanisms. Example of Class 1 components include resistors, capacitors, transistors. Class 3 components are complex hardware elements, usually integrated circuits. These components have many operating modes and work over a wide range of parameters. They often require software or configuration to operate correctly. Their behavior can only be understood by carefully studying their datasheets and manuals, and they usually include internal safety mechanisms. Examples of Class 3 components include microprocessors, microcontrollers, ASICs. Classifying Class 2 components is the most challenging part. These components are simpler than Class 3 but more complex than Class 1. They usually have fewer operating modes, a limited range of values, simple data sheets. Unlike Class 3 components, Class 2 components do not have internal safety mechanisms. Examples of Class 2 components include simple sensors such as fuel or temperature sensors, independent ADCs, external watchdogs. As discussed, Class 1 and Class 3 components are easier to identify, while Class 2 require more careful analysis. We also have covered this topic in detail in our blog. You can search for ISO 26262 hardware component classification to learn more. Now let's look at the steps for performing the evaluation of hardware elements. To start with, we need to understand three key inputs that are required before we begin the qualification process. First, we need to collect all the relevant safety requirements for the specific hardware component. This includes technical safety requirements and the hardware safety requirements that are applicable to that component. Next, we need to collect safety analysis and testing evidences from the component vendors. This information is usually available in the documents such as PPAP report or similar equivalent document. This document summarizes the analysis performed by the vendor and also provide details of the tests they have already conducted on their side. Finally, we need information about the failure modes of the hardware components and its fit rate. This helps us to understand how often the failure can occur and how they may impact safety. Once we have all these inputs, we can start the qualification process based on the hardware class we have already identified. For Class 1 components, ISO 26262 does not require a separate evaluation. This is because when we develop the hardware board according to ISO 26262, the normal testing and analysis activities are already sufficient to ensure the correct functioning of the Class 1 components. For Class 2 and Class 3 components, evaluation is required. The first step here is evaluation by analysis. This means we review the data provided by the vendor and combine it with our own safety analysis, hardware metrics, verification results, and confirmation review reports. Based on this, we check whether the risk of violating a safety goal is sufficiently low. The next step is evaluation by testing. Here, we use both vendor test data and our own internal test results. This includes hardware integration testing, fault injection testing, robustness testing, stress testing, and also manufacturing test coverage. For Class 3 components, there are some additional expectations. We need to ensure that the hardware component is developed according to a recognized safety standard. We also need to verify all safety related functionalities and apply proven measures based on the field experience or well tested design principles. One more important requirement for Class 3 component is the implementation of an independent supervisory circuit. This circuit should be able to detect failure of the Class 3 components independently. Finally, an important note from ISO 26262 Part 8 Clause 13.4.4.1. Class 3 hardware elements are expected to be developed according to ISO 26262 itself. This means the standard does not recommend qualification as an alternative for Class 3 components. With that, we have covered how to perform hardware element qualification. Thanks for watching and see you in the next video.